everyone, welcome to the session. So in this particular session, we will talk about that what are the steps required to construct an algorithm. I hope that before coming to this session, you already have watched my previous video where I have already discussed about that what do we mean by an algorithms and what are the important properties of an algorithm, right? Now in this session, let's talk about that, okay, if suppose some problem is given to us, then how basically we reach to the final solution where we will say that, okay, here we get the optimized code. Here we get the code that is very much lesser in terms of the time and space complexity that I will talk about in the future sessions as well. So before coming to that part, let me try to give you one question based on the previous video that you have watched. Let's see who can answer it correctly. So when I give you the question, just pause the video, answer me, and then just unpause the video and see the correct answer for that. I hope maximum students will give the correct answer. Let's get started. So first of all, the agenda of this session is to talk about the steps which are required to construct any algorithm. Okay. So this is the important agenda that we will try to solve it today. But before that, so let me try to give you one code here. For example, I hope everyone knows what is loop. So loop is something where whenever we are using a loop means we are trying to repetitively use the same statement again and again some n number of times, where n varies from user to user. Now, suppose I am saying that I am using, so specifically in Python, if I will talk about, we have usually while loop and we have usually for loop. So here I am using while loop. So how while loop will work? While inside that there is some condition that we used to write. So until or unless that condition is satisfied or it is true, so the statement inside the while loop will run. Suppose I am saying that inside the while loop there is a print statement where I am printing the name of mine, which is Priya Bhatia. Okay. So this is the name which I want to print inside the code. Now, can you tell me with this code, first of all, this code which is while loop is there, inside that always true condition will be there, and then it will go inside this statement and it will try to print that. Can you just tell me that whether you will consider this as a valid algorithm or not? Just pause the video and you let me know. I hope that maximum students have answered it correctly. This is not an algorithm. Now, why is that so? Just refer to my previous video where I have talked about the properties of an algorithm, right? I hope everyone remembers. Where, what was the first property I told you? That whenever you are writing any algorithm, it should complete or it should run after some finite amount of time. But here if you will try to observe, this true condition will always be true, because what I am saying is that inside that I am writing true only. So it means that this print statement will run infinite number of times. This print statement will run somehow, I am saying, infinite number of times, which is actually not desirable, because this very first property that we have discussed in our previous session, where we have talked about that the valid algorithm is something which will just terminate after some amount of time, is not applicable here. So that's why it's not an algorithm. I hope everyone find it very easy. It's just the overview of whatever we have discussed in the past session. Now, let's get started with the today's part, where what we want is that we want to discuss that what are the steps required to construct any algorithm. The very first important step is the problem definition. Now, whenever any problem is given to you, first of all, you have to see everything. What are the constraints which are given to you, right? What are the important parameters which are given to you? What are the important test cases which are given to you. All these things, you have to understand the problem definition. First of all, I would say end to end. End to end, you should have the knowledge of the problem definition that you are trying to discuss or which you are trying to solve. The second important thing, after getting the insights of the problem definition, now you should think that, okay, for this problem, what particular algorithm should I apply? So in this step, in this phase, second phase, you need to think what should be the designing part. Either I should go for divide and conquer designing. Am I able to solve the problem with the help of divide and conquer approach? Or I will be able to solve the problem with the help of a dynamic programming? Or I would be able to solve the problem with the help of something called as greedy approach? Or and many more. Let me write like this because I know maximum students are not aware about any of the approaches. So there are so many approaches that we have with the help of which we can design an algorithm. All the approaches we will cover up in this course. But the important point is that once you get an idea of all these approaches, after seeing the problem definition, you have to think which particular designing part should I go first in order to execute my code. After getting the sense of that you will get for sure once you will get a knowledge of all these approaches that we have, which I have written here. After getting the sense of that, just draw a flow chart, which will try to give you a sense end to end that whatever designing part you are trying to think that it will be solvable or it will help you to get the final solution. Is that fine or not? Right? What you can do is that you can try to start from the problem definition. You will try to write the designing algo that you are thinking and you will get to the end solution. Once you will be able to draw that, the next important thing that you can do is that you will go to the testing phase, where whatsoever test cases is given to you in the problem definition, what you can do is that you can pick up each and every test case. You will try that whatever output is given to you in the code is actually the same which you are getting with the help of this designing algorithm part, or is it something different? If suppose it is exactly the same that you are getting, it means somehow you are going in the right direction. If suppose the answer, the output that you are getting is not the same, it means that you have to go back and you have to see this designing algo approach and you have to maybe go for another approach. For example, to solve any problem, first of all, you think that divide and conquer is better one. You go there, and then you find out that in testing phase, the test cases are not getting the correct output. So what you will do is that try to think more. Try to think the other algorithms. Try to think which particular approach will work best for that, right? Once you will be able to get all the correct test cases, after that what will happen is that it means now you are going in a very right track. Not the last, but the least important part is the implementation. Here what will happen is that now you know that you already have tested your logic, whatever you are thinking. Now this implementation can be done in any programming language. So what you have to do is that whatsoever logic you have think about, or whatsoever logic you think that is giving the correct output, whether it's with the help of a dynamic programming or divide and conquer or greedy approach or backtracking, you have to just write that particular code in terms of any programming language. It can be Python, it can be C, it can be C++, it can be JavaScript, anything, any favorite language of yours, right? So any programming language. Once you have written down the code, now obviously if you have already tested with your logic all the test cases, it should run, right? It's just the changing of the syntax that is required. Finally, what you have to do is that you have to do the analysis. You have to do the analysis. What is the meaning of analysis? That in depth I will talk about in my next session, but to give you a gist of this, for example, I have given you one problem, which is P. Now, there are so many students, suppose there are 3 students who got more than one solution to solve that same problem. Means S1, S2 and S3 are the 3 valid solutions that I have for the same problem. Now, which particular solution is working the best? out of these three, suppose all these three are giving me the correct output that I have already talked about in phase number 4. But now I have to compare and tell you that which particular solution is the best one. How do I compare? That is done with the help of this analysis part. And that is the part from where we will start our algorithms portion. So in the next upcoming session, I'll try to discuss this analysis portion in very much depth. And I'll try to show you that what factors are there with the help of which we will try to see that which particular solution is the best one. Usually, there are two important factors, which is something called as time complexity, and another factor is something which we call as a space complexity. When we talk about time complexity, it is something which is the time required to execute the code. When we say space complexity, it is the extra space required to execute the code. And usually, there is a trade-off between the time complexity and the space complexity. When you try to decrease the time complexity, you have to somehow compromise with the space complexity. When you try to increase the space complexity, you have to somehow able to decrease the space complexity. But now you can just consider in terms of milliseconds. For example, S1 code is running within 100 milliseconds, S2 code is running within 80 milliseconds, and S3 code is running within 50 milliseconds. Which code will you prefer? Obviously, you will say that the last one, because we don't have patience to wait so long to get the output, right? So usually we prefer time complexity over space complexity, and obviously if there is a scenario where both are less, that's the best one. What we want as a best optimized code, we want both of them to be low. But if you will be able to get a lesser time complexity over the sake of the higher space complexity also somehow, it's also fine. But later on in the next upcoming video, I'll talk about in very much depth about this analysis portion. And in that, you will be able to get a proper sense out of it. But I hope that with this particular session, at least you will be able to get an understanding that what are the important steps which are required to construct any algorithm. So there are 6 important steps that I have talked about: problem definition, designing, drawing of a flow chart, testing, implementation, and finally the analysis part. If you still have any doubt, do let me know in the comment section. We'll see you all in my next upcoming video, where now I will talk about what is analysis all about. Bye-bye everyone. Happy learning to all.